right? I'm going to substitute that y down here. So I've got 2 times 4 minus 2x plus 3x equals 8. So I've got 8 minus 8x plus 3x is equal to 8. So minus 5x is equal to 0. X equals 0, if I did that right. So if x is 0, so y plus 2 times 0 is equal to 4, so y equals 4. So my answer is x equals 0, y equals 4. That's 2 equations, 2 unknowns. Y'all have done that before. So if we can get this to 2 equations, that's our one equation. We take this one, we take the ax, write it in terms of ay, bx, write it in terms of by, then we got 2 equations, 2 unknowns, then we can solve it. Once you get that one piece, then all the rest will fall in place. That's just one way you can do it. You don't have to take the ax and write it in terms of ay. You can take the ay and write it in terms of ax, and the by and write it in terms of bx, and substitute it in with this equation. There's no one way to do it. It's just kind of an approach. Any other questions with this or other problems on the homework? It's a pretty hard problem. So don't feel bad if you're struggling.
So the force we pull should be equal to AX?
No. The force you're pulling is on the rope. So the force you're pulling should be A. Oh, that's another question we're going to isn't it? What's A equal to? A is equal to B. Yeah, there's another question. That might make your solution a little easier.
What's if the angles are the same?
What's that? It's a rope. Was it loose at the bottom or was it tied? There was possibly friction, wasn't there? Because it was going through the brick.
Those 2 magnitudes won't be the same.
Okay. Because, I was thinking a pulley, but you don't have a pulley. So we can't say that. We didn't have a pulley here. You could have enough friction where you wouldn't have the equal. Actually, if you had a pulley, that thing would be right in the center. And it may not have been. Because you had that you had a brick, right? Was it the center block?
It was on a pulley, but it was offset to be this exact problem.
Assuming the pulley was frictionless, you shouldn't have, the line should have the same amount of force.
Well, it wasn't frictionless.
Okay.
Yeah.
Okay, so you don't have to assume that you can work the problem either way, but just assume that there's friction in the pulley, in that pulley at the bottom. So don't use that A is equal to B. If you had a frictionless pulley, then you can assume that. That's the whole point of the pulley is not having friction, so that the rope has the same force on both sides and it rolls real easy.
You assume that like AY and BY each are holding half of the weight?
No, what you can assume is this. AY plus BY is 35 pounds. Think of it, I know it's hard to see with that one, but it's close. Imagine, let me draw a more exaggerated version of it. Imagine it was like this. You can almost thinking like something hanging off, a little fishing line hanging out here and a bobber. And I'm just pulling up to the side here. I mean, on this system here, which one's holding most of the weight? This one's, if you got a really heavy weight, this one has a lot of force on it, and this one's just enough to pull off the side, real easy. So they don't have the same. This one, they're going to be closer because the angles are similar, but they're not exact.
Okay.
Anything else? Okay.